Hey guys, so today I'm going to be showing you what happens when we have a set amount of force propelling an object and we change the weight. We'll see how it affects the acceleration. So remember that F equals ma, force equals mass times acceleration. And so we're going to keep F constant with this plunger. We're going to use the same amount of force every time. We're going to be changing the weight by adding mass into the cart. And we'll see how that affects the acceleration. So each time I shoot this cart off of the wall here, you'll see a spike, and that spike will show us the acceleration of the car. And so as we increase the mass in the car by piling these in one after the other, we should see the acceleration get smaller and smaller. So let's go ahead and try it out. So the first trial is going to be with no mass except for the cart's mass, so the lightest test. And we're going to do 2 plunger for each of these trials. So let's go ahead and do our first trial. And so we see a shot right here. That is the first acceleration. So we're going to check that 9.08 meters per second squared. So that's the acceleration, the max acceleration that the cart experienced when it pushed off of this wall here. So we're going to hide that for now. Remember that first high point. It's not always going to be at the same time in the graph because it depends on how long it takes me to press the plunger after hitting start. Let's try one more here. So same thing. But now we've added some mass in there, so it's more massive, has more mass, more kilograms. And let's see what happens this time. Much less, right? So same plunger, boom, 5.1 this time. Let's try it one more time. This time with even more mass, so we've piled in more here, and we're going to test it again. Okay. 3, 2, 1. Boom, our lowest one yet. So now if we look at this, we can see that each time I've I've added more weight to it. So we have 9 meters per second squared, our fastest acceleration. That was when the cart had nothing in it. Then we had 5.1 meters per second squared. That's when we added one set of mass to it. And then we have 3.512 meters per second squared. That's with 2 of the masses in it. So as you can see, as we increase more mass, the acceleration goes down as long as we keep F the same. Let's watch what happens if we increase the force. So we're going to go ahead and clear that. So this time, I'm not going to change the weight in the cart. I'm only going to change the amount of force. So we're going to go 1 plunger, 2 plungers, 3 plungers. So first, 1 plunger. Start, and boom. Now I'm going to do 2 plungers. Oh, come on. 3, 2, 1, boom. And 3 plungers. Now this can be hard for the cart to recognize because it's going to happen very fast, but here we go. And what we can see this time, if we put all our runs there, is our first run. Oh, actually, we had 4.8 meters per second. That was with the smallest amount of force. Run 2. Run 2, we got 9.5 meters per second squared. And run 3, 14.215 meters per second squared. So as you can see, if we increase the force, the acceleration goes up. And so if we keep mass the same, the force causes the acceleration to go up the more force we put, right? If I push you harder, you're going to move faster. If I push an object harder, it's going to move faster. And if we keep the force the same, but just increase the mass, then the object's acceleration goes down. That would be like having 2 cars with the same engine, but one is heavier and one is lighter. The heavier one obviously isn't going to go as fast because that engine has to push more mass. So hopefully this helps you understand those 2 concepts a little more, just how force and acceleration are correlated and how mass and acceleration are correlated. Thank you guys, and talk to you next time.